In this video, we're going to talk about the average rate of change. So before we actually do the average rate of change business, we first of all have to get some definitions straight and understand that, first of all, average rate of change for a linear function is your regular slope. It's rise over run, it's the change in y's over the change in x's, and so on and so forth. When we talk about a nonlinear function, though, like the one in this picture, it's not a straight line, so it's nonlinear. And we want to know the average rate of change. We have to go about the process just a little bit differently. We're going to take 2 points on this function and ask ourselves, what would the average rate of change between them be? So we're going to start with a point over here, and we'll do a point up here somewhere as well. To make sure that we keep this in general terms, we're not going to give these points any numeric value, but we will say that this point here is at some x value, which we'll call x1, and this point to the right is at some x value, which we'll call x2. They also both have their own y values. So this point right here is going to be f of x1, and this point here for the second point will be f of x2. So the y values for those corresponding x points. So we want to find the average rate of change between them. And in order to do this, we actually calculate a slope, like a line, by making a line through those 2 points, which would look something like this. And this kind of line has a special name. This is called a secant line. And that's actually what we're going to find the slope between. And that will tell us, on average, how much our rise over our run is equivalent to. So let's go ahead and put this in terms of a formula. So we're going to say the average ROC, rate of change, is equal to, now to find slope, it's difference in y's over difference in x's. So this is going to be f of x2 minus f of x1, those are my y values, divided by x2 minus x1. So very, very similar to the way that your slope formula looks, except we're not using y's, we're using f of x's. Understand, too, that this is the change, or delta, in y over your change in x's, which is also the same thing as the slope of the secant line. Remember that m always represents slope. So that's the general idea of what we're doing when we're talking about average rate of change for non-linear functions. So let's go ahead and put this into a problem and see if we can do this. Alright, so here's our first example. So find the average rate of change of the function f of x equals x cubed minus 3x from x1 equals negative 2 to x2 equals 0. Now, if you want to, you can put this in a graphing calculator to kind of get a feel for what the picture looks like, but I'm going to go ahead and draw one up. So generally, this is what it looks like. This is a cubic function. It does pass through the origin. And what's important to do immediately is to get some y values for these x's. You can do this by using a graphing calculator, or what I suggest, because you're not always allowed a calculator, plug those x values into your function and see what you get. So let's go ahead and start that process. So I'm going to do f of negative 2, that's my first x value, equals negative 2 cubed minus 3 times negative 2. So all I did was plug negative 2 into the function. Negative 2 cubed is negative 8. Negative 3 times negative 2 is positive 6. And this yields a negative 2 altogether. So one of my points in here, I'll just say that here it's right here on the picture. It's negative 2, comma, negative 2. So that's important. So this is f of my x1 value, okay? So I now have a y value to go with it. Let's try to do the same thing for the other 0, which is, for the other x value, which is 0. So f of 0 equals 0 cubed minus 3 times 0, which is a big fat 0. So this is my f of x2. So this is a point 0, 0. So that is the origin. So the line on which I'm finding the average rate of change, remember, is called a secant line, and that's going to pass through those 2 points like so, and we're going to go ahead and find the slope of that line. So I'm going to follow the formula from the previous page, which is f of x2, which is 0, minus f of x1, which is negative 2, divided by x2, which is 0, minus x1, which is also negative 2. So this all becomes positive 2 divided by positive 2, which is equivalent to 1. So that's simply my average rate of change. So average rate of change equals 1. And that's it. That's all there is to it for this kind of a situation. So what about an application-based problem? So let's take a look at one of those next. Alright, so here's our word problem. So the distance s in feet, a moving car is from a stoplight, is given by the function s of t equals 20t to the 2/3, where t is time in seconds. So find the average speed of the car from t1 equals 0 to t2 equals 4 seconds. So we're going to grab our formula for average rate of change. So it's going to have to be varied a little bit because we have different variables now. We don't have f and x, we have s and t. So this should look like s of t2 minus s of t1 over t2 minus t1. So that's our formula for finding the average speed for this particular problem. Now I know what my t2 and t1 are, so I'm going to put those in. So 4 minus 0. And to find s of t2 and s of t1, we're going to have to take those values and plug them into our function, which will give us, when I plug 4 in to our function s of t, I will get 160. And when I plug in 0, I just get a plain old 0. So this is going to simplify to 160 over 4, which is equivalent to 40. Now, remember that with word problems, if you are working with units, it's really important to include those units in the answer so that it makes sense. So this 40 represents an average rate of change of something per something. That's what a rate of change is. So we're going to say that this is 40 something per something, and the way that you look at that is, what is the unit for my function up here in the y value? And it tells us that s is feet. So that's what this is going to represent. So this is feet per what? So my time happens to be seconds. So this is feet per second. So 40 feet per 1 second is about how fast I'm moving toward a stoplight for this particular function. So that's all you need to do for your word problems, and that's about as difficult as this gets. So anytime you're trying to find average rate of anything, you always revert back to your slope formula in some way, shape, or form. And that will conclude this tutorial.